So hello and welcome guys. Now we're going to be talking about calculating thermal energy, or how to calculate thermal energy. To understand thermal energy, we need to go into the types of energies, and the first one is the internal energy. Now the internal energy is the sum of kinetic and potential energy inside of the system. Okay, so whenever one of these changes, so the internal energy changes. Okay, that's one. Second is we need to understand something called thermal capacity and specific heat capacity. Okay, now thermal heat capacity, or thermal capacity, is basically a property of the object that tells you how much is that object is gonna be resilient to change in temperature, basically how much of energy he can take before its energy changes. Okay, so that is a thermal capacity. Specific heat capacity is being more specific, so it's the amount of heat energy required to raise 1 kilogram by 1 degree Celsius. Okay, so any matter, it needs some sort of energy to raise it. So for specific heat capacity, that 1 kilogram will need a certain energy to get raised by 1 degree Celsius or 1 degree Kelvin, basically. Okay, so that is being said, we have to understand there's a one main law, which is the heat energy. You can say E is equal to mc delta T. You can use the Q, whatever suits your preferences in math. You can use it. I sometimes use the Q, sometimes I use the E. It depends on the situation. But basically, we know that energy or power is equal to energy over time. So energy in general is equal to power multiplied by time. Okay, so now we remove the Q, which is the energy. So power multiplied by time is equal to the mass multiplied by specific heat capacity multiplied by the change in temperature. Now what is this? Now this law is used to calculate the temperature, or the thermal energy needed if you want to change the temperature of a certain mass of a certain material. So that's the energy, right? And that's the certain mass you want, with a certain specific heat capacity multiplied by the change in temperature. So that is T2 minus T1. So let's say you have a certain amount of water. Let's have 1 kilogram of water. You want to change it from 20 degrees to 100 degrees. How much is that going to be? That's the idea of using thermal energy. Okay, so if you look at this example, I have here a 1 kilogram of material. I supplied 1000 joules with a change of 2 degrees Celsius. Okay, so what happened here? Now we can calculate the heat capacity of this object. It required 1000 joules to get changed by 2 degrees Celsius. So that heat capacity itself is energy divided by time. So 1000 divided by 2, which is 500 joules per degree Celsius. Now, if you want to call it specific heat capacity, you just divide by kilograms. So that would be a specific heat capacity. So that would be 500 joules per kilogram per degree Celsius. That's one way of looking at it. So this is another example of the thermal energy. Now you have a mass of 1000 kilogram with a specific heat capacity of 200 joules per kilogram per degree Celsius, and you want to change its temperature from 20 to 100. So that is 80 degrees change. So delta T is basically 80. Okay, so if we apply this law, Q equal mc delta T, so we know the mass is 1000, the C is 200, and the change in temperature is 80. So you get a thermal energy of one big number. So usually you convert it to standard form. So that would be 1.6 times 10 power 7 joules. That's you requiring, that's the thermal energy required. Now if you're given, for example, the time, so that was done in 2 hours, and now he's asking you for the power supplied. So we can use this big law, power multiplied by time is equal to mc delta T. We already got this, which is 1.6 times 10 power 7, and we want to know the power. We know the time is 2 hours, so that would be 2 times 60 times 60. So to convert it into seconds, the equating that in the equation, you get 222 watts, which you can round out to 2200 watts, and that's how you can use that to calculate the power given. Now we're going to see more of questions on that, but this is the main idea, this is the main concept. Okay, thank you for listening.